Hey guys, this is Group 4. We are a consulting group that travels and regularly attends meetings with companies throughout Arkansas. For this case, we are looking at the maximum profit we should be able to make based on the amount of small and large meetings our employees can attend in 1 week. So for this, we have two different types of meetings. We have special meetings and routine meetings. Now, routine meetings are our typical meetings that we would have through a normal week. Special meetings are different in that we may have more prep time or just time beforehand. What we wanted to do is look at the number of jobs we should be taking for each type of meeting to find our maximum profit. Now, before we go off doing this, we have 5 constraints that we found based on the minutes that we are allowing for each type of constraint. So the types of constraints that we have are travel time, the time at the actual meeting, prep time, time after the meeting, and then time talking with the client beforehand, whether that be getting the bids or anything like that. So now that we have our constraints, I'm going to go ahead and show our solver solution, where we just used our constraints that we had found on left-hand and right-hand side for our objective at 2200. It was set at 1800, and after changing our variable cells right here, it is changed to 2200. So the next thing we did is we solved each of our constraints, and we solved for R for each of these. And then after that, we put it into our formula, and we just set it from 1 to 10 because we already knew at that point that we were looking for a number somewhere between 5 and 10 more than likely. So using those numbers, we just plugged in each of the equations that we solved for R. And this is where we find our extreme points. Now, we know that this is our feasible area because each of our equations is set less than or equal to. And since we never had to divide by a negative, we never had to switch any of our signs. So this is a feasible area we're working with. And from what we found, the 2 points that crossed within our feasible area were right here. Those would be our 2 extreme points. Now, those 2 extreme points that crossed were our equations 4 and 3 and 3 and 1. So using those 2 extreme points, that's what we solved for. Now, when we solved for both of those, after a little bit of algebra, we found that our S, when we set equation 1 and equation 3 equal to each other, was 6. And after plugging back into equation 1, we found our R equaled 7. Now on the flip side, when we set equation 4 and equation 3 equal to each other, we found about 5.36 to be our S, and after plugging in, about 8.9 to be our R. Now, the reason I rounded down for this is because, kind of like in a earlier example, since it wouldn't make sense to take a fraction of a job, we just went ahead and rounded down to 5, since we couldn't round up, since our other value was 6. And then we changed our R accordingly. So that is what we have so far. We still need to do the lingo coding and sensitivity analysis. That would help flesh all of this out. And then any other constraints y'all could think of for this would be very helpful, or any other comments where you're definitely not done with this, but any help would be appreciated. Thanks, guys.